Alright, now this week we're talking about factoring expressions. After this lesson this week, you should be able to identify the greatest common factor of terms, and the terms will include a term with a variable, not just numbers. You will be able to use the distributive property to factor algebraic expressions, and you'll be able to write a term as a product involving a given factor. There are three ways to factor an expression. You can use the greatest common factor, which is the GCF. You can use a rational number. Remember, rational numbers include positive, negative, zero, fractions, decimals, both repeating and non, and then just our normal counting numbers as well. And we will also be able to use a negative number to factor. Alright, first I got a couple of vocab words for us here. The first one would be factors. It should be review, but factors are numbers that are multiplied to give a product. So for instance, if I have the numbers 2 and 3, if I multiply them together, it gives me 6. So 2 and 3 are factors of 6. Next one I have is greatest common factor, GCF. Again, review. The biggest factor that two or more products have in common. So if I keep with my 2 and my 3 here, that gives us 6. I also have, and I look at, well, we'll actually look at this in a minute. I'll give you an example of greatest common factor in a minute. But we have factoring an expression, and this is new to us. This is what we're doing in this lesson. When we're factoring an expression, we're writing the expression as a product of factors. So let's break that down a little bit. So we're writing an expression. We know an expression is going to be something like 4x plus 2. We have that term with a variable. We have an operation we're adding, and then we have a constant. Product, remember product means multiply, and factors, we said factors were numbers that are multiplied to give a product. We'll see how this all comes together. But when you're factoring an expression, little note here, you can use the distributive property to factor any rational number from an expression. And we'll see how that's done. And I just kind of gave you the distributive property down here one more time, just in case you don't have it written down. Right here where I have a plus and a minus, that's my shorthand, like my shortcut for writing both the addition and the subtraction rule at the same time. So it's just A times B plus or minus C is equal to A times B plus or minus A times C. And so if it's a plus here, it'll be a plus here. If it's a minus here, it'll be a minus here. But you can go back to earlier videos and see the rule if you need to. So in yesterday's video, you saw how you can factor out the greatest common factor and rewrite the expression. So I'm going to factor out the greatest common factor here. We'll just go over it real quick to make sure that you understand. So if I have 24x minus 18, we want the greatest common factor of 24x and 18. So this is step 1, is we have to find the greatest common factor of these two terms. So for factoring out the greatest common factor, what I'm going to do first is look at the factors of 24x. So I'm going to start listing, well, x is a factor here, so I have x. And then I'm going to start looking at the number 24 itself. So I know 1 is a factor because 1 is a factor of everything. So 1 times what gives me 24? 24, and I'm going to write it way over here so that way I can do my lower numbers over here, my big numbers over here, and work my way to the middle. And at that point, when I know I'm in the middle, there won't be any more terms and I've got all of the factors. And you'll see that as we work through this. So 1 is a factor. Well, 24 is even because 4 is an even number, so we know that it can be divisible by 2. We know 2 can go into 24. Now it's a matter of how many times. So we put my 2 right here. 2 divided by 24 gives us 12. And so that's my other factor, 2 and 12. Notice that as I go, I have 1 and 24, 2 and 12, and they'll go and meet in the middle. So next, 24, 2, well, let's try 3. Can 3 go into 24? Yes, it can. It goes 8 times. So I have a 3 right here, and I put my 8 right here. Alrighty, after 3 comes 4. Can 4 go into 24? You betcha. So we have 4 times 6. So the only number in between 4 and 6 is 5. 5 times 5 is 25, not 24, so I can't have 5 as a factor, and I'm all done. These are all my factors of 24. 1, 2, 3, 4, 6, 8, 12, 24. There are no other factors of 24. So I can move on to 18. And again, there's no x, so I won't have an x as a factor. So I'm going to start with 1. 1 times what? 18. Again, the 8 here is even, so I know that it's divisible by 2. So 2 will be a factor, and 2 times 9 gives me 18. I'm going to try 3. 3 times 6 is 18. So I have 4 and 5 in the middle right here. Well, 4 times 5 gives me 20. 4 times 4 is 16, not 18. And like we said up here, 5 times 5 is 25. So there's no other factors. The factors of 18, always and forever, will be 1, 2, 3, 6, 9, and 18. So I am done with step 1. I have all of my factors listed out. So now we're going to look at step 2. What factors do they have in common? Well, they both have a 1. They both have a 2. Both have a 3. And you can circle this, but I don't want my colors to, mix together and ruin the markers, so I'm just writing it down here. But you can totally circle them if you're writing this down on paper. 4 right here. There's no 4 right here. So 4 is not in common. They don't share it, so we cannot put 4 down here. They both have a 6. 24, one of the factors is 8, but 8 is not a factor of 18. 9 is not a factor of 24. 12 is not a factor of 18. 18 is not a factor of 24. And 24 is not a factor of 18. So the only factors that they have in common, that 24 and 18 have in common, is 1, 2, 3, and 6. So those are my factors that I can pick from in step 3. Step 3 says, of the factors that they have in common, so that's 1, 2, 3, and 6, which one is the largest? Well, the largest factor that they share out of 1, 2, 3, and 6 would be the biggest number, 6. So my greatest common factor for this problem is 6. And now that we have that, we can go ahead and move on to the problem itself. Alrighty, so now that we know that our greatest common factor of 24x minus 18 is 6, we can use that greatest common factor to factor the expression. So here you see my original, and I'm going to fill out my little dashes right here because I'm using the distributive property to factor it out. I'm going to take out a 6 from 24, and when I do that, I'm left with a 4x, because 6 divided by 24 is 4, and I keep my x because I did not take that outside because I didn't have a greatest. My common factor was not 6x, so I'm just taking out the 6. I'm not taking out the x. That stays inside of the parentheses. We are subtracting over here, so we will subtract here. So now we do 6 goes into 18, so we have a 6 on the outside, and 6 goes into 18 3 times. So we have a 3 on the inside right here. And that is step 4. Now step 5, we're going to simplify it to get our answer, because we want our answer. So up here I filled in Then I have 6 times 4x minus 6 times 3. And so now step 5 says I'm going to simplify this in the green. I don't know if you can tell that it's green. But you're going to simplify what's in green here using the distributive property. So remember, our distributive property said A times B minus C is equal to A times B minus A times C. So if you look, this would be A times B minus A times C. So I'm rewriting it so that I have A times B minus C. So here 6 would be my A. So I have 6. 4x is my B. 4x. We're subtracting here, so we'll subtract inside. And then my C is 3. And so now this is our answer. 6 times 4x minus 3. And we're done. This is what you would give me as your answer. I've had some people trying to solve for x and do different things like that, and they just give me a number. That is going to be next week that we are solving for x. This week and last week and the past couple weeks, I still want to see the expression that you have simplified. Alright, if you need more help using the greatest common factor, please let me know and I can get you some extra help with that. But right now we are moving on to what today's assignment actually is. We are factoring out a rational number and simplifying that way. So we're going to factor out 1/2 out of the 1/2 x plus 3/2. I know fractions are scary. Bear with me. So in step 1, we're going to write each term as a product. So that means we're multiplying 1/2 and another factor or another number. We're multiplying 1/2 and something else. Alright? So we have 1/2 x. We're going to think 1/2 x is 1/2 times what? You'll see down here in blue, I wrote it out. 1/2 x equals 1/2 times what? So I have 1/2 right here. I have 1/2 right here. What goes in my blank? Well, I have an x right here. I don't have an x over here yet. So in my blank, I'm going to put x. Then we're going to look at 3/2 is 1/2 times what? Well, I have 3/2 equals 1/2 times what? Well, if I break this down, it would just be 1/2 plus 1/2 plus 1/2 gives us 3/2, or 3/1. So 1 times 3 is 3, 2 times 1 is 2. You get 3/1, or you can just call it 3. Either way works for me. So another way that you can kind of think about this one, right, the 3/2 part, is we're looking for 1/2. How many 1/2 is in 3/2? If you broke it up, and we get 3. Alright, now we're using our handy dandy distributive property to factor out the 1/2. This is step 2. So remember we have the 1/2 x plus 3/2. And we just said that another way that we can write that is by saying 1/2 times x plus 1/2 times 3. Because we factored out that 1/2 over here on this other, on my other board. But now that we have it broken up and we have factored out that 1/2, that is what we wanted to do, we now just want to simplify it. So again, I kind of wrote it out with the blanks. So up here we have 1/2 times x plus 1/2 times 3, and I just copied this straight from up there. And so now with our answer, we're going to use that distributive property again to combine everything. So we pulled out the 1/2. Ooh. Alright. So like I said, we pulled out that 1/2. And now we got to make sure that we include everything else that we have. So we have our x right here. We're adding right here. So we'll add inside. And we have our 3. And so now if I were to distribute this out, I'd say 1/2 times x gives me 1/2 x. 1/2 times 3. That'd be 1 times 3 is 3 over 2 times 1 is 2. We're adding inside, so we'll add outside. And that gives us exactly what we started with. 1/2 x plus 3 over 2. 1/2 x plus 3 over 2. We just wrote it differently, and that's all we're trying to do here is rewrite the expression in a different way. Alright, so this next practice problem, we have 1/2 n minus 1/2. So again, we're going to factor out the rational number here. Let's focus a little bit more. Cool. Okay, so our rational number here, if you can see it, it's 1/2. And we don't even have to think through, you know, how many 1/2s is in 1/2. It's 1. 1/2 is 1/2. So we're going to say 1/2 and minus 1/2 is equal to, and this is where we're going to pull out that 1/2. So we have 1/2 times, right here, 1/2 times n. We're subtracting, so we'll subtract, and we're subtracting 1/2. And what do we multiply 1/2 by to get 1/2? Well, by 1, because 1 times anything is anything. Alright, and now I use my distributive property to combine everything, or to pull it out. So 1/2 is what goes on our outside. Inside the parentheses, I have whatever's left over, whatever is not 1/2. So I have n. I have a subtraction sign. Jason's crying in the background. I'll try to be quick on this. And I have a 1. Alright, sorry. So our final answer here is 1/2 times n minus 1. Alright, this is going to be our last example today. I know we didn't do a lot of examples today, but you know, I hope that I walk through them well enough for you. We'll go over some more examples tomorrow. But for this one, we have 3/4 p minus 3/2. Now first looking at this, we'll notice that they have different denominators. Remember, we can't really compare things if the denominators are different. That would be like me saying that I gave somebody 3 slices from a pizza that was cut into 4s, and then I gave somebody 3 slices that were cut into 2s. So that would be, if I gave somebody 3 slices of pizza and it was cut into 4s, that's cut into 4s, and I gave them 3 pieces. If I gave somebody 3 slices that were cut into halves, well, there's half. I would need a second pizza. That's not half. Let's redo that real quick. So that's 1/2, 2 halves, 3 halves that I gave them. This person gets way more pizza than this one, even though this looks like you'd be getting more pizza, right? So what we need to do first is make sure that our denominators are the same so we can accurately compare these two fractions. So I can make this 3 halves into something over 4 pretty easily. So I'm going to say 3 over 2 times something will give me a number over 4. So 2 times what gives me 4? 2 times 2. What I do to the bottom, I do to the top. So 3 times 2 is 6. And so my new expression here is going to be 3 over 4p, 3 over 4p minus 6 over 4. And now I can compare. So remember, what we do first is think, what can I pull out? So I'm going to try to pull out a 3 over 4. So if I think 3 over 4p is 3 over 4 times what? Then I have 3 over 4p is going to be equal to, we'll just say equal to, equals 3 over 4 times p. Then if I said 6 over 4 is equal to 3 over 4 times what? So I can't say something like that. My denominator has to be 1, right? Because 4 times what will give me 4? 1. Now 3 times what will give me 6. Notice I'm asking the same questions that I did up here when I found my new fraction, when I changed my denominator. I'm using the same exact numbers that I would, or the same questions, I'm sorry y'all. So 3 times what gives me 6? 2. So I'm going to have 3 over 4 times p and 3 over 4 times 2 as my new expression. So 3 over 4 times p, and we were subtracting, so we're going to subtract down here. We're going to have 3 over 4 times 2. Remember that 1 you don't really need at the bottom there. You can write it, you don't have to write it. I'm happy either way. So now we're going to use that distributive property to combine what we need to and pull out what we need to. So 3/4 is the same, so I'm going to pull that out, 3/4. And now in my parentheses goes whatever I did not use. So I did not use my p, I'm going to put that inside. I didn't use my subtraction, I'm going to put that inside. And my 2, I'm going to put that inside. So my final answer is 3/4 p minus 2. Now let's go ahead and just check my work. You know, sometimes that's nice. So I have 3 over 4 times p minus 2 was my answer. 3 over 4 times p, because we are now using the distributive property to distribute the number on the outside to the inside. So 3 over 4 times p gives me 3/4 p. We subtract on the inside, so we'll subtract down here. 3 over 4 times 2. 3 times 2 gives me 6. 4 times 1 is 1. Nope, 4. 4 times 1 is 4. And so if I were to simplify that fraction, we have 3 over 4p minus, if we subtract this, divide this by 2 over 2, I get 6 divided by 2 is 3, 4 divided by 2 is 2, and that is what our original problem was. This answer down here that I got is correct. Alright, so in no way, shape, or form is this required. Again, no way, shape, or form do you have to do this. It is not an assignment. But if you need extra practice, if you really just are not understanding anything that we are doing, you can try some of these IXL lessons. Really anything underneath R, that's R, anything under R. Hold on, let me look at what level we're at. Okay, so we are level I math. Under math, you'll go to level I. And all these lessons and more are underneath R. R12 will help you solve inequalities using properties. So that's the associative property, the commutative property, those things that we looked at. R14 is adding and subtracting linear expressions. R16 is factoring, or finding the factors of linear expressions. So that's what we're doing this week. R11 is multiplying using the distributive property. That's what we did last week. And R9 is sorting factors of variable expressions. That's more of what we're doing this week. For here, the two factoring, it might seem a little different than what we're actually doing and how I'm setting it up. But if you get confused, you can come ask me, or you can look at, I know it kind of explains things. If you get a question wrong, it'll walk you through how to do it. But remember, I'm still here to help. You can email me, post in Google Classroom, join our daily video chats, or if you would like some tutoring, that's still available, and it can be during our group video chat every day, or if you want to get a group of friends together, we can all talk, or if you just want to kind of jump on individually. I've had a couple people ask me to do that, and we are quickly able to fix their misconceptions, and they end up getting hundreds on their quizzes, on their ed puzzles for the day. Please reach out to me if you need help or if you do not understand, because just putting that you don't know as your answers does not help me help you. And I'm just here to help you succeed. I miss you and hope that you're doing great.